6 flashes of light erupted on the moon, while 4 astronauts floated in total silence behind it. No radio, no signal, no line back to Earth. They were farther from home than any human beings in history, watching explosions bloom across the surface of a world most people still think of as silent, frozen, and dead. And then, as Orion curved around the far side, the crew looked down and saw something that did not match the moon we thought we knew. The colors were wrong. The terrain was alien. The shadows looked impossible, and one astronaut said something that stopped mission control cold. Humans probably have not evolved to see what we are seeing. That line was not about one crater, or one flash, or one beautiful view through a spacecraft window. It was about the entire experience. Because behind the moon, everything changes. Distance changes. Silence changes. Scale changes. And the meaning of home changes. Tonight, we are going there. Not to the moon you know from childhood. Not the pale disk hanging over a quiet neighborhood. We are going to the other side. The side no human eye had seen up close in more than half a century. The side where Earth disappears. The side where the moon stops looking familiar and starts looking ancient, hostile, and disturbingly alive. Over the next 2 hours, we are going to follow Artemis 2 from the launch pad to the far side blackout, from impact flashes to Earthrise, from cosmic radiation to magnetic scars, from grief to awe, from science to something deeper than science. Because what the Artemis 2 crew found behind the moon was not just data. It was perspective. And it begins with the return. For more than 50 years, no human being left low Earth orbit. Think about that. We built space shuttles. We assembled a permanent station in orbit. We sent robots to Mars. We launched telescopes that could look back toward the beginning of time. But we did not go back to the moon. An entire generation was born into a world where lunar travel belonged to history, not the future. History. The moon became archival footage, black and white voices from another era, bulky suits, grainy television, crackling radio transmissions from men who sounded both calm and impossibly far away. The Apollo program had done the unthinkable so completely that it almost felt mythological afterward. Then the myth froze. And that is part of what makes Artemis 2 so strange. It is not humanity's first trip to the moon. It is something more psychologically unsettling than that. It is a return to a place we once visited, then abandoned long enough for that abandonment to feel normal. That matters. Because when human beings discover a place for the first time, the emotion is one thing. But when we return after half a century, the emotion changes. Now there is comparison. There is memory. There is unfinished business. And there is a question hanging over the whole mission. Why did it take this long? Part of the answer is technical. The moon is not close in any meaningful human sense. It is close on a cosmic map, but in practical terms, it is brutally far. It takes a powerful rocket, years of testing, layers of redundancy, a heat shield capable of surviving a violent return through Earth's atmosphere, a global communications network, and an entire architecture of planning just to send people around it and bring them back alive. Part of the answer is political. The Apollo program was born inside a Cold War. It was a contest, a demonstration, a national proof of capability and will. Once that contest cooled, so did the urgency. And part of the answer is deeper. The moon exposes a harsh truth about exploration. Going once is spectacular. Going back is commitment. The first time proves that something is possible. The second time begins to ask whether we really mean it. Artemis 2 is that second question. Not a landing. Not yet. Not footprints. Not yet. But a line in the sand. A declaration that the moon is no longer a museum exhibit in human history. It is becoming a road again. And the crew reflected that shift. Artemis 2 was not built to look like Apollo. That would have been too easy, too nostalgic, too small for what the mission was trying to say. Apollo's crews were extraordinary, but they also reflected the narrowness of their era. Artemis 2 looked different. A woman, a black astronaut, a Canadian, an American commander who had lived through grief most people never imagined carrying into public life, much less into deep space. That difference was not cosmetic. It changed the symbolism of the mission. It changed the emotional texture before the spacecraft had even left the ground. Because this was not just a replay, it was a handoff, a continuation without imitation. And from the moment the mission began, the message was clear. We are not going back to relive Apollo. We are going back to reopen the future. The launch itself was thunder and controlled violence, as all launches are. Fire beneath steel. Human bodies strapped to precision and hope. The old contradiction of every crewed mission, the most advanced thing our species can build, still begins by setting itself on fire. Then ascent, then orbit, then the long push away from Earth. And that is when the psychological geometry of the mission began to shift. In low Earth orbit, Earth still feels near, huge in the window, present, dominant, protective. But once the translunar injection burn is complete, once the spacecraft commits to the arc that will carry it outward, something subtle happens. Earth stops feeling like the environment. It starts feeling like the destination you are leaving behind. That is the first real threshold. Not the launch, not separation from the rocket, not even orbital insertion. The real threshold is when the spacecraft stops circling home and starts falling away from it. That is when the mission ceases to be spaceflight in the familiar sense and becomes something older, stranger, and far more exposed. Because from that point on, there is no quick rescue, no easy abort, no simple path home. Distance becomes real, and as that distance grows, another truth begins to emerge. We were never designed to think clearly across scales like this. The numbers become absurd almost immediately. Hundreds of thousands of miles, days in transit. Communication delays that are still small compared with Mars, but large enough to remind you that space is not listening in real time. A ship no larger than a closet carrying everything the crew needs to survive. Inside that capsule, the astronauts float, eat, sleep, speak, observe, and wait. Outside that capsule is vacuum. Perfect, ancient, indifferent vacuum. And ahead of them, growing slowly in the windows, is the moon. Not as a symbol, not as a photograph, not as the familiar coin in the sky, as a place. A real place with mass, gravity, shadow, impact scars, and an entire hidden hemisphere that still has the power to surprise us. The farther Artemis 2 traveled, the more the mission stopped feeling like a headline and started feeling like an encounter. An encounter with distance, with silence, with history. And with the first unsettling realization that the moon, for all its familiarity from Earth, remains in some important way unknown. And that unknown began to open wider as the crew approached the place where every lunar mission changes character. The far side, because that is where voices go dark, and where the moon stops being scenery. There is a phase in every deep space mission that matters more psychologically than it does visually. Nothing dramatic happens outside. No explosion, no emergency, no giant mechanical event. And yet everything changes. For Artemis too, that phase began when the Earth started to shrink enough that it no longer filled the imagination automatically. At first, it is still the dominant object behind you, blue, white, luminous, familiar. The planet seems enormous because it is everything you have ever known. Every city, every memory, every language, every war, every love story, every funeral, every celebration, every ordinary meal ever eaten by a human being happened there. But as the spacecraft moves outward, Earth begins to behave like all distant things. It gets smaller, and the human mind does not like that. Because part of being human is living with the illusion that home is always nearby. Even when we travel far across oceans or deserts or continents, home remains part of the same world, same sky, same air, same planet beneath our feet. Deep space breaks that instinct. It turns home into an object. A visible one, yes. A beautiful one, yes. But an object, something you can place in the window, something you can lose behind a horizon. And that shift is more than emotional. It is cognitive. The crew of Artemis II was trained for procedures, contingencies, communications, navigation, observation windows, spacecraft systems, and emergency protocols. They were trained to work under pressure, to work tired, to work in silence, to work with discipline. But no simulation on Earth can perfectly train a human being for the sight of Earth becoming small enough to fit behind your thumb. That is not because the image is complicated. It is because the image is too simple. One world, one sphere, one brightness against the black. And with that simplicity comes a dangerous clarity. You begin to understand just how thin the line is between us and everywhere else. Our atmosphere is not a vast sky from out there. It is a film, a haze, a layer so delicate that from enough distance it looks almost accidental, like condensation on glass. And once that realization settles in, the moon begins to feel different too. From Earth, the moon is a companion, a light, a presence, sometimes romantic, sometimes eerie, sometimes so familiar we stop looking at it. From cislunar space, the moon changes role. It becomes a boundary, a wall, a body large enough to hide a spacecraft, block radio, erase line of sight, and separate 4 human beings from the rest of their species. That is what makes the far side of the moon so psychologically rich. Not because it is spooky in some superstitious way, not because it is the dark side, which it is not. The far side receives sunlight, just like the near side. It is not permanently dark. What makes it powerful is this: it faces away from us, always. Not for a few hours, not by chance, always. Because the moon is tidally locked to Earth, it rotates at the same rate it orbits us. One face toward us, one face away. A cosmic habit so old and stable that it shaped human imagination itself. For billions of years, We have looked at one hemisphere. The other one remained hidden, and hidden things acquire weight. They become psychological space as much as physical space. The far side of the moon is not just terrain. It is the oldest hidden surface humans have ever imagined regularly and seen rarely. And Artemis too was going there. That matters not just for viewers, but for the crew themselves, because the far side is the point where a mission stops being merely distant and becomes physically disconnected. Behind the moon, radio dies. No matter how modern the ship is, no matter how powerful the antennas are, no matter how many people are in mission control, the moon is simply in the way. That is one of the things space does over and over again. It strips technology of its arrogance. You can build the finest spacecraft on Earth. You can network continents. You can train thousands of experts. And then a silent sphere of rock reminds you that physics still has the final word. By the time Orion approached that threshold, the crew had already crossed a subtler one inside themselves. They were no longer just traveling. They were leaving the environment of constant human contact, leaving the possibility of immediate reassurance, leaving the noisy civilization that produces an answer for nearly every inconvenience, and heading toward 40 minutes in which the most advanced mission of its generation would be governed by one ancient rule. Wait. That was the rule for mission control too. Wait for the signal to vanish. Wait through the blackout. Wait for the spacecraft to emerge. Wait and trust the trajectory. Trust the numbers. Trust the burn. Trust the vehicle. Trust the people inside it. And while everyone on Earth prepared to wait, the crew prepared to see something no training could make ordinary. Because the moment the signal disappeared, the moon would stop being a destination and become an eclipse of civilization itself. And in that silence, something else would happen. The crew would watch homes sink away. Not metaphorically, literally. Because before Earth rises again, Earth has to set. The blackout behind the moon is one of the purest examples of reality overpowering language. We call it a communications blackout. That sounds procedural, manageable, almost routine. But listen to what the phrase actually means. For 40 minutes, 4 human beings traveled behind a celestial body that blocked every direct radio signal between them and Earth. No voice from mission control. No status call. No comforting chatter. No one to hear them in real time. The moon itself became a wall. One moment, the Deep Space Network is tracking Orion, reading telemetry, monitoring systems, following every movement. The next moment, silence. There is something profoundly unnerving about a mission so technologically complex being reduced in that instant to absence. On paper, the blackout is expected, planned, timed, modeled, understood, but experience is not paper. Inside Orion, the crew could know exactly what was happening and still feel the physical, animal reality of isolation. Human beings evolved on open ground under atmosphere and weather, inside social structures where sound travels, light scatters, and help exists somewhere in the distance, even when it is not immediate. The blackout behind the moon removes all of that. No wind, no ambient noise, no civilization in the background, no visible sign of other people. Just a small cabin drifting behind a world of rock. The far side blackout is not merely loneliness. Loneliness still assumes a world beyond you. This is separation, and separation changes perception. Ordinary details become charged. A voice in the cabin, a glance through a window, the way a checklist sounds when read aloud, the tiny movements of crewmates floating in the same confined volume. Suddenly, every human presence inside the spacecraft becomes more vivid because there is nothing outside the spacecraft that belongs to humanity at all. Even the word outside becomes strange. Outside is not landscape. Outside is not horizon. Outside is vacuum and stone and distance. And then Earth disappears. That moment deserves its own pause. As Orion moves behind the far side, the crew watches the planet sink below the lunar horizon and vanish. The only home our species has ever known slides out of sight behind another world. That image is so simple that it is almost unbearable. You can spend your whole life using the word Earth as if it means ground, environment, reality itself. Then one day, if you are one of a microscopic number of humans in history, you look out the window and see Earth behaving like a star that can be hidden. The emotional effect of that cannot be overstated, because part of the human nervous system still believes home is stable because it is visible. Home is where the ground is, where the air is, where the voices are, where the world continues around corners and past horizons. To watch home drop out of sight is to feel, for a moment, how contingent all of that really is. And yet, inside Orion, the work continues. That is another beautiful contradiction of spaceflight. The most extraordinary emotional experiences often occur while astronauts are still doing their jobs. Observing, reporting, logging, tracking, looking. It is never pure poetry out there. It is poetry under procedure. And that may be why astronaut testimony matters so much. The language comes out grounded, half scientific and half overwhelmed, because they are living in both states at once. The far side blackout is full of that duality. It is terrifying and routine, beautiful and technical, planned and existential. Mission control waits in Houston. The crew floats in silence behind a wall of rock. Humanity becomes, for 40 minutes, two separated scenes in the same story. One scene is crowded with engineers, consoles, screens, voices, fluorescent light, and calculation. The other is a sealed cabin moving through shadow, where every system has to function without immediate rescue, and every person inside knows that the rest of the species is now physically on the other side of the moon. And it is in that silence that the far side of the moon finally comes into view, the way almost no human beings have ever seen it. Not as a map, not as an image stitched together from orbiters, not as a textbook diagram, as a presence, a real, cratered, light-struck, shadow-drowned presence filling the windows. The moon we know from Earth begins to disappear. A different moon emerges, and at almost the same time, the crew witnesses something else. Flashes, small at first, brief, sharp, impossible looking if you do not know what you are watching. But they are real, and they are violent. Because even behind the moon, in total communications blackout, space is still busy throwing rocks. From Earth, the moon has a reputation it does not deserve. We call it silent, dead, still, frozen in time. And in one sense that is true. The moon has no weather, no oceans, no forests, no atmosphere, no birds, no cities, no movement that resembles life. But stillness is not the same as peace. Artemis 2 proved that in the most cinematic way imaginable. During the flyby, the crew saw 6 flashes erupt on the lunar surface. 6 brief detonations of light. Not reflections, not artificial beacons, not optical mistakes. Impacts. Rocks from space slamming into the moon hard enough to produce visible bursts of light. And the fact that they were visible from the spacecraft window matters. That means those tiny-looking flashes were not tiny in energy at all. This is where the moon's lack of atmosphere changes everything. On Earth, most incoming debris never reaches the ground. It burns up high overhead. What we call shooting stars are the graceful deaths of tiny fragments, beautiful because our atmosphere destroys them. The atmosphere is not scenery. It is armor. The moon has none. A grain of dust, a pebble, a fist-sized stone, a larger fragment broken off from some ancient collision elsewhere in the solar system, if it intersects the moon's path, it does not blaze gently through sky. It strikes at full speed. And full speed in space is not intuitive speed. It is not highway speed. It is not the speed of bullets. It is the speed of orbital violence, tens of thousands of miles per hour. Enough to vaporize rock on contact. Enough to excavate small craters instantly. Enough to turn something physically small into something energetically dramatic. The moon is hit all the time. That sentence sounds abstract until you imagine what it means physically. Not once in a while. Not every so often. All the time. The surface is under constant bombardment by micrometeoroids, sporadic meteoroids, debris from comet trails, fragments from collisions that happened long before human civilization existed. The moon is not a relic that was scarred once in the ancient past and then left in peace. It is being scarred now. Artemis 2 simply happened to put human eyes in the right place to see some of that violence directly. And what the crew saw reaches beyond spectacle. Because 6 flashes on a single flyby are not just fascinating visuals, they are strategic information. Future missions are not planning to wave at the moon and leave. They are planning to return, to orbit, to land, to stay longer, to build infrastructure, habitats, power systems, landing zones, surface operations. Possibly one day, if the architecture grows far enough, permanent presence. Every one of those ambitions has to answer a simple question. How do you live on a world that is constantly being hit? A rock the size of a marble may not sound threatening until you remember its speed. A rock the size of a coin, the size of a golf ball, even the size of a grain of sand, becomes a different object entirely when it is moving through vacuum without resistance. A bullet is dangerous because of speed. A meteoroid is dangerous because of absurd speed. And unlike on Earth, there is no weather report for this at human scale. No warning siren, no cloud pattern, no thunder, just impact. One moment, a surface is still. The next moment, a flash appears and a crater is born. For the crew of Artemis 2, seeing those 6 impacts was like catching reality unmasked. The moon stopped being an icon and became an environment, a hostile one. Not in the theatrical sense, not as a villain, but in the more troubling sense of simple indifference. The moon does not protect what stands on it. It does not cushion. It does not burn away danger overhead. It does not absorb the violence of space before it reaches the ground. Everything gets through. And once that realization arrives, the entire romance of lunar exploration, acquires a harder edge. Moon bases are no longer just sleek concept art. They are structures that must survive bombardment. Spacesuits are no longer just symbols of heroism. They are thin barriers against kinetic events too fast to see. Surface operations are no longer just triumphant human footsteps in dust. They are choreography inside a shooting gallery. That is why the flashes matter, not because they are rare or supernatural, because they are normal. The moon's danger is not its exception. It is its baseline, and that baseline was made even more unsettling by the context in which the crew saw it. Not while chatting comfortably with Earth, not while a global audience watched in real time with direct contact. They saw some of it in blackout. 4 people in silence, watching explosions on another world, while the rest of humanity could not hear them. It is hard to imagine a better image for what exploration really is. Not the poster version, the real version. Beautiful, unscripted, and edged with hazard, but the flashes were only one layer of strangeness. Because once the crew kept looking, something even more surprising emerged. The moon itself did not look the way it was supposed to. Not from there. Not in that light. Not to human eyes. And that is where the story turns from danger to mystery. Because the far side of the moon is not simply more cratered than the near side. It is another face entirely. Every child grows up under the same illusion, that the moon has one face. Not because we are foolish, because that is what the sky gives us. The same markings over and over. The dark plains, the bright highlands, the shapes cultures turned into rabbits, women, men, and stories. The moon becomes familiar not because we understand it, but because repetition disguises strangeness. We see one hemisphere for so long that we begin to confuse familiarity with completeness. Artemis, too, breaks that illusion. The far side of the moon is not just the near side turned around. It is geologically different, visually different, emotionally different. The first thing that hits you is the density of craters. The near side has broad, dark maria, those ancient lava plains that smooth large portions of the landscape and create the patterns visible from Earth. The far side has almost none of that relief. Instead, it is highlands, impact scars, overlapping basins, pale terrain, crater on crater on crater, all the way to the horizon. The landscape looks older because it is exposed older. On Earth, geology gets rewritten constantly. Wind, rain, rivers, glaciers, tectonic plates, oceans, and vegetation all conspire to erase ancient violence and replace it with new surfaces. The moon does not do that. It remembers in raw form. And the far side remembers more brutally. Part of the reason is crust thickness. The moon's crust is not uniform. The far side's crust is significantly thicker in many regions. That extra thickness mattered billions of years ago when internal heat and impacts created opportunities for magma to rise. On the near side, thinner crust meant lava could flood giant basins and create the maria we now see as dark blotches from Earth. On the far side, magma had a harder time reaching the surface, so the lava plains never developed on the same scale. The result is a moon with 2 geological temperaments. One hemisphere smoother, darker, more volcanically reshaped. The other rougher, brighter, older, more battered. A two-faced world, but structure is only part of it. The Artemis 2 crew also described colors that challenged the popular imagination of the moon as pure gray. Not cartoon colors, not wild fantasy colors. Subtle ones, brownish tones, lush hints, greenish whispers in mineral-rich regions under certain light. This is the sort of thing that sounds trivial until you realize what it means. For decades, much of humanity's lunar visual knowledge came through imagery filtered by camera systems, calibration choices, published contrast, spectral bands, compression, and viewing conditions far removed from the actual human eye in real time. The moon in our minds is partly a technological moon, a mediated moon. What Artemis 2 brought back was the beginning of a more lived moon. A moon encountered by trained observers whose brains were processing shifting angles, changing light, depth cues, contrast changes, and subtle tone differences all at once. That human layer matters, not because the eye is objectively superior to instrumentation. It is not. Instruments can detect far more than the naked eye. But instruments do not wonder. Instruments do not compare in the moment the way a trained brain does. They do not say, this ridge feels wrong, that basin looks older, that color shift seems meaningful, that terrain does not match expectation. Humans do that, and sometimes the most important scientific contribution is not a measurement itself, but the recognition that something deserves a measurement. That is why the far side is so powerful as a narrative and scientific object. It is a hidden hemisphere in the literal sense, but it also symbolizes everything about nature that familiarity tends to flatten. We think we know the moon because we see it constantly. Then we go there and realize that our knowledge was partly front-facing, like knowing a person only by their public expression. The far side is the private structure, the hidden asymmetry, the part that forces a rewrite. And like many rewrites in science, it prompts a deeper origin story. How did the moon end up like this? Why would one hemisphere run hotter, erupt more, flood its basins, and wear a face so different from the other? The answer likely goes back to the moon's birth itself, to the giant impact origin story, to the molten early moon, to radioactive elements distributed unevenly, to cooling histories that were not symmetrical, to billions of years of consequences cascading from one ancient imbalance. That is one of the most haunting things about planetary science. A world can spend billions of years revealing the consequences of its first few million. The moon's split personality may be one of those consequences. One side got one fate, the other got another. And then there is water, or rather, the lack of it in many far-side materials. Dryness on the moon is not the dryness of deserts. A desert is still a place shaped by water's possibility. The far side of the moon can be dry in a way that feels almost conceptual. Not a thirsty place, a place where water barely belongs at all. That matters for science. It matters even more for settlement. Because every future dream of living on the moon eventually comes down to a short list of brutally practical needs. Air, water, shielding, power, thermal control, mobility, protection. And the farther you get from those basics, the more quickly the poetry of exploration becomes logistics. The far side may be one of the most fascinating places in the inner solar system. It may also be one of the worst places to try to live without massive support. That is the other thing Artemis 2 gives us. Not just wonder, discrimination, a clearer sense of which parts of our moon are inviting only in imagination and which may actually support a human foothold one day. Still, even as the geology deepened and the hidden hemisphere revealed its asymmetry, the most affecting sight was not the far side itself. It was what happened when the crew emerged from behind it. Because after enough darkness, even home becomes a revelation. And when Earth came back into view, the mission changed tone again. Not from science to emotion, but from one kind of truth to another. There are images that belong to history. Then there are images that change history. Earthrise belongs to the second category. The first time humans saw Earth rise above the lunar horizon, something irreversible happened to human perspective. We had gone to look at another world and discovered, with frightening clarity, the fragility of our own. Artemis too stepped back into that experience. After the blackout, after the far side, after Earth had vanished, the crew watched it return, blue and white above the lunar edge. It is hard to overstate how emotionally loaded that image becomes when home has been absent. We live our entire lives with Earth as the background assumption of existence. The ground below, the sky above, the weather, the environment, the unspoken certainty. Then for 40 minutes it is gone, and when it rises again, it is no longer background. It is object and miracle. That is why astronauts struggle to describe it. The image is visually simple, a sphere above a horizon. But psychologically it is devastating. Because Earth, from that distance, looks nothing like what it feels like from inside history. It does not look divided. It does not look ideological. It does not look crowded. It does not look noisy. It does not look political. It looks singular. One world. The overview effect is the term often used to describe the cognitive shift astronauts feel when they see Earth from space. But the phrase can sound almost too clinical for what is happening. This is not a neat conceptual adjustment. It is a fracture in scale, a collapse in the mental hierarchy of importance. Things that once seemed overwhelming suddenly feel local and temporary. Borders vanish. Conflicts shrink. The entire machinery of human self-importance is revealed as a thin layer of meaning, painted over a planet that, from outside, simply looks alive and alone. That does not solve our problems, but it does reorder them. And perhaps that is part of why this moment matters beyond the astronauts themselves. A civilization that repeatedly sends people outward and hears them come back with the same report that Earth looks fragile, shared, and indivisible is receiving a kind of moral data, whether it wants it or not. Not policy, not legislation, not a programmatic answer, just perspective. And perspective can be more destabilizing than information. The crew of Artemis 2 was not only inheriting Apollo's path physically, they were inheriting its psychological gift. Apollo 8 gave humanity Earthrise in the middle of a turbulent century. Artemis 2 gives it back in another turbulent century that may need it just as much. Because the picture is not nostalgia. It is a correction. A reminder that our daily scales are not the only scales available. A reminder that civilization is not the whole story of reality. It is a surface event on one bright planet under one star among hundreds of billions. That does not make human life meaningless. It makes it astonishing and vulnerable. When Earth rises in the window after blackout, the crew is not just looking at beauty. They are looking at dependency. at every system that sustains human life, packed onto one small sphere. Oceans, atmosphere, agriculture, climate, biosphere, memory, language, culture, all confined to a place that from lunar distance looks shockingly finite. There is no visual excess in that image, just the opposite. It is the austerity of it that destroys you. One home, no visible backup, and yet the emotional force of Earthrise is not despair. It is tenderness. That may be the single most important thing the moon teaches people who see Earth from it. Not fear first, tenderness first. The kind of tenderness that comes from seeing how breakable something is without concluding that breakability makes it weak. Earth is not weak because it is fragile. It is precious because it is fragile. That distinction matters. The crew felt it. Apollo felt it. The generations watching from Earth feel some diluted version of it too, even through screens. And still, the mission could not stay suspended in emotion alone. Because alongside that psychological transformation, NASA had a sharper scientific reason for wanting humans around the moon again. Not just to see Earth, not just to feel awe, not just to touch history, but to watch the moon with human eyes under conditions no camera alone could fully replace. That is where the mission turns again. Back toward observation, back toward detail, back toward the surprising argument that in one of the most technologically advanced missions of our time, eyeballs still mattered. And what those eyes saw would change how scientists think about the very act of looking. The modern instinct is simple. If you want precision, use machines. And in many cases, that instinct is right. Cameras do not get tired. Sensors do not become emotional. Spectrometers do not blink. Orbiters can map, measure, and return consistent data over years. So why put people there? Why ask human beings to do visual science in a cramped capsule with changing light, condensation, fatigue, glare, emotional overload, and all the imperfections of biology? Because the human eye is not just an optical sensor. It is attached to a brain evolved for pattern recognition. That matters more than it sounds. A camera records. A trained observer perceives. Those are not the same thing. As Orion moved over the moon, the lighting changed continuously. Craters that looked shallow under one angle deepened under another. Subtle color differences appeared, vanished, and reappeared. Texture became legible in shadow, then flattened under direct light. Relief changed minute by minute. A camera can capture frames from that experience. A trained human being inside the experience can notice relationships. This is one of the reasons geologists still value field observation on Earth, even in an age of satellite imaging. To stand in a landscape, to move through shifting light, to turn your head, to compare surfaces, to feel scale in real time, to react to what surprises you, that produces a layer of understanding that images alone cannot always deliver. Artemis, too, extended that logic to lunar space. The crew did not simply look at pre-selected targets as if checking boxes. They described what they were seeing, compared impressions, adjusted to light conditions, interpreted visual nuance, reported surprise. That last part is easy to underestimate. Surprise is information. When an observer says, "This does not look like I expected," science pays attention, because expectation is built from prior models, imagery, and assumptions. If a trained person in the window says, "The terrain feels rougher, the color warmer," the contrast stranger, or the shadows more extreme than anticipated, that is not random chatter. It is a signal that reality is offering something the model did not fully anticipate. And that is precisely what human exploration is good at. Not just confirming known things, but catching the mismatches. There is also the matter of visual continuity. Orbital images are powerful, but they are still slices, moments, specific lighting geometries, specific perspectives. Human eyes operating continuously across a moving trajectory create a stream of perception that can integrate change in a way separate images cannot. It is the difference between studying still photographs of waves and standing on a cliff watching the sea actually move. Both are useful. One is alive. And yes, the human eye has limitations. It gets strained. It adapts slowly between bright and dark. It can be overwhelmed. It sees less of the electromagnetic spectrum than instruments do. But those limitations compared with a singular advantage. Humans narrate. A camera stores data. A person says, "Wait, look at that." And sometimes those 4 words are the beginning of a better question. The Artemis 2 mission leaned into this. The observations were not an afterthought. They were part of the scientific architecture. People in Houston were listening not just for procedures, but for descriptions, for language, for the raw texture of real-time observation from human minds looking at another world. This gives the mission a subtle philosophical depth. We often speak as if robots and humans are competing approaches to exploration, but they are complementary approaches to contact. Robots are better at endurance, exposure, consistency, and precision. Humans are better at synthesis, intuitive comparison, and the generation of immediate meaning. The problem is not deciding which is superior. The problem is remembering that data without human meaning is incomplete for a species like ours. That is one reason viewers respond so strongly to crewed missions. Not because humans are more noble than robots, but because when a person speaks from another world, the distance collapses in a different way. The landscape stops being purely scientific and becomes experiential. The moon becomes less like a map and more like a place someone has actually seen. That is what great exploration does. It does not only increase knowledge, it changes intimacy. And sometimes that intimacy does not stay scientific for long. Sometimes it turns personal, painfully personal. Because in the middle of all this looking, all this describing, all this science, the Artemis 2 mission moved into a moment no machine could ever have created. A moment about grief. A moment about memory. A moment that explains, better than any mission statement, why human beings belong in the story at all. There are moments in exploration history that survive not because they prove what humans can do, but because they reveal what humans carry. Artemis 2 had one of those moments. During the lunar flyby, as the crew observed the surface and spoke with Earth, one of the astronauts proposed naming a crater after Carol, the late wife of Commander Reed Wiseman. To understand why that moment matters, you have to understand what spaceflight usually looks like from the outside. Systems, numbers, trajectories, hardware, risk models, launch windows, engineering triumph. All of that is real. But underneath all of it are people living entire human lives before they ever strap into a spacecraft. They marry. They lose people. They become parents. They grieve. They continue. And sometimes those private histories travel with them farther than any audience remembers to imagine. When Carol's name was spoken near the moon, the mission changed register. For a moment, it stopped being primarily about distance and discovery. It became about the persistence of love inside a place built to strip everything down to survival. That is what made it so moving. You expect science at the moon. You expect history. You expect grandeur. What you do not expect is tenderness. Not that kind of tenderness. Not the kind that takes the most unreachable landscape in a human life and turns it into a memorial. Because that is what naming does. It anchors meaning in geography. It says this place will not just be coordinates, or ejecta, or regolith, or crater morphology. It will also be memory. Only humans do this. Only humans look at a world of stone and impact and say, this place now carries the name of someone we loved. And suddenly, the vastness of space does not erase personal life. It intensifies it. That is one of the quiet truths of exploration. The farther you go physically, the more concentrated certain emotions become. Love does not disappear under scale. Grief does not become less real because the backdrop is planetary. If anything, the backdrop makes those feelings more visible. A small act inside a huge environment becomes luminous. In a mission full of spectacle, Carol is the emotional center because it proves that the human heart survives translation into deep space. Not metaphorically. Actually, it comes aboard in the cabin with you. That matters for public meaning too. Space programs do not live on engineering alone. Engineering makes missions possible. Human feeling makes them matter to everyone else. A crater named after a lost wife will be remembered by audiences who could not tell you the exact dimensions of a basin or the name of a systems controller. That is not a failure of public understanding. It is a clue about how meaning works. We remember science best when it is carried by human stakes. Carol is not sentimental padding in the middle of a scientific mission. Carol is evidence that this mission belongs to the species that launched it. Machines can map impact structures. Machines cannot mold. Machines can image the moon in exquisite detail. Machines cannot float in silence and feel the ache of naming part of another world after someone who should have been there to see it. That is not a small distinction. It may be the entire point. Because when people ask why we send humans instead of only robots, this is part of the answer. Not the only part, but an irreplaceable one. Humans do not just collect facts. They transform place into story. And story is how civilization remembers why it reaches outward in the first place. The Carol moment also sits in contrast with everything else happening around it. The moon remains what it is. Hard, ancient, airless, dangerous. It is not softened by our feelings. It does not care what we call anything on its surface. And yet the indifference of the moon is exactly what gives the gesture its power. To name something in an indifferent universe is one of the oldest human acts. To say this matters, this person mattered, this grief matters, this love will travel farther than I ever thought it could. The crew embraced. Voices changed. The distance between science and life collapsed. For a few minutes, lunar exploration was not a symbol of national ambition or technological prowess. It was a husband, crewmates, and the persistence of someone absent. And then, as always in space, the mission moved forward. Because the moon does not pause for emotion, There was more to observe, more to describe, more to survive. And the very next thing the crew encountered would drag the story from tenderness back into strangeness. A line across the moon, a boundary between light and dark, so visually extreme that it made the surface look less like a planet and more like some shattered, impossible world from fiction. Astronauts call it the Terminator, and in the right conditions, it shows you what the moon is really made of. The word sounds dramatic. The Terminator. And in a sense, it is. But the term itself is simple. It is the boundary between lunar day and lunar night, the moving line where sunlight falls away into darkness. From Earth, it looks graceful, a curved edge across the moon's face. From near the moon, under the right geometry, it is something else entirely. It is revelation. Low-angle light is merciless. It does not flatten. It exposes. When the sun sits near the horizon relative to the lunar surface, every ridge, crater rim, escarpment, and mound throws long shadows. Tiny topographic differences become legible in dramatic relief. Features that might disappear under direct overhead light suddenly leap into visibility. This is why photographs taken at one angle can fail to prepare a human being for what the moon looks like at another. Under Terminator light, the surface becomes severe, jagged, layered, shredded by shadow. The crew of Artemis II described isolated peaks catching sunlight, while valleys around them had already fallen into darkness, islands of terrain in blackness, bright edges suspended over invisible depth. Some mountain peaks looked almost snow-covered, not because the moon had snow, of course, but because fresh, reflective rock against deep shadow created such extreme contrast that the eye reached instinctively for an Earth analogy. That instinct is important. When humans encounter alien landscapes, we borrow from home to describe them. Snow, islands, seas, shorelines, walls, wounds. Language keeps trying to domesticate the unfamiliar. But the Terminator resists domestication. It makes the moon look like what it actually is, an impact-sculpted body without atmosphere or weather, where billions of years of cratering remain visible because almost nothing softens them. From overhead light, the moon can seem smooth in broad terms, familiar, mild. From Terminator light, it looks dangerous. That is not just an aesthetic effect. It is scientific leverage. The long shadows reveal structure. Tiny changes in elevation become measurable in appearance. Fractures, collapsed rims, basin rings, rough terrain, bright fresh craters, all emerge differently. A trained observer can infer tremendous amounts from how the light behaves across a surface. This is another place where human seeing matters. Not because the eye is magical, because the brain connected to the eye is immediately comparative. It notices when something looks too bright, too steep, too fractured, too isolated. It turns image into interpretation on the fly. The Terminator also forces a more philosophical recognition. The moon is not smooth because we know it. It only seems smooth because we were far away. That is a lesson that applies far beyond astronomy. Distance makes rough things look simple. The nearer you get, the more structure appears. The more history appears. The more violence appears. The moon is not a silver coin. It is a wreckage archive. And the Terminator is the lighting condition that makes that archive almost impossible to ignore. There is another reason this matters for future exploration. Humans may one day build near regions of permanent shadow, especially near the poles, because shadowed craters can preserve water ice. But shadow is not simply absence of sunlight. It is thermal extremity, navigational challenge, visibility problem, engineering complication, and scientific opportunity all at once. The moon's light boundary is not just beautiful, it is operationally serious. Where sunlight touches and where it does not will determine power strategies, landing windows, thermal management, habitat placement, and the viability of extracting resources. A world without air turns light itself into infrastructure. The Artemis 2 flyby did not solve those future challenges, but it made them feel immediate. The crew was not looking at abstract topography anymore. They were looking at the raw visual logic that future lunar presence will have to obey. And the Terminator tied everything together. Impact scars, shadow geometry, fresh craters, brightness anomalies, the sheer roughness of the far side. All of it converged into one increasingly uncomfortable truth. The moon is not just beautiful, it is dangerous. Dangerous not because of monsters or fiction or mystery in the cheap sense. Dangerous because its conditions are exacting, because its hazards are normal, because its silence offers no warning, because what makes it visually spectacular also makes it physically unforgiving. And once the crew had seen 6 impact flashes and the Terminator's brutal relief, there was really only one question left to ask next. What keeps hitting the moon? And how often? Because if Artemis is not just going back to touch and leave, but to build and stay, then the bombardment is not background scenery. It is the environment itself. Every world in the solar system lives inside a storm. We do not feel that storm on Earth because the atmosphere catches most of it for us. The sky burns the evidence before it reaches the ground. That protection is so complete, most people never think about how much debris actually falls toward Earth every day. The moon does not have that luxury. No atmosphere means no burnup. No burnup means everything that intersects its path arrives at the surface at full velocity. This is one of the great lunar misconceptions. People imagine the moon as quiet because there is no air, no weather, no waves, no forests rustling, no visible signs of living movement. But quiet is not the same as untouched. The moon is constantly being struck. There are large impacts so rare that they become geological events. There are small impacts so common they become texture. And between those extremes is a continuum of bombardment that never truly stops. Much of this debris is sporadic. Fragments from ancient collisions, comet dust, asteroid chips, leftover rubble from the solar system's violent youth, still circulating on intersecting paths. Some of it arrives in streams associated with meteor showers, when Earth and Moon pass through debris trails left by comets. On Earth, we gather under clear skies and enjoy those showers as beauty. On the Moon, the same celestial debris becomes artillery. That inversion is one of the most useful mental flips lunar science offers. The thing that delights you from your backyard may become a hazard on an airless world. This matters at every scale. Tiny particles pit exposed surfaces and wear materials down over time. Slightly larger particles can damage equipment. Larger meteoroids can create flashes visible from afar and excavate new craters in an instant. And the speed is the whole point. Space does not need large objects to be destructive. It only needs fast ones. A pebble moving at a leisurely human speed is nothing. A pebble moving at tens of thousands of miles an hour is an explosion waiting to happen. That is why future surface operations on the moon will have to think like military planners, civil engineers, and biologists all at once. Structures may need shielding or partial burial. Habitats may need regolith piled over them for protection. Vehicles, suits, radiators, solar arrays, comms equipment, and even route planning will have to incorporate a world where impacts are not anomalies, but a statistical certainty over time. This is where lunar exploration stops sounding poetic and starts sounding infrastructural. Can a habitat survive a decade? Can a suit handle micrometeoroid puncture risk? Can solar systems tolerate dust and impact damage? Can orbital platforms manage debris environments over long durations? The answers will not come from romantic language. They will come from modeling, observation, and the kind of visual evidence Artemis 2 added to the record. The 6 flashes the crew saw are important because they are immediate. Humans remember immediacy. You can tell someone the moon is bombarded, and they nod. You tell them astronauts watched explosions on the surface from orbit, and suddenly the hazard becomes real. And hazard on the moon is never isolated from the broader logic of deep space living. The same lack of atmosphere that makes impacts dangerous also leaves astronauts exposed to temperature extremes, radiation, and the abrasive persistence of fine lunar dust. The moon is hard not because it is exotic in a cinematic way, but because it strips away nearly every protective layer Earth supplies by default. Earth gives us pressure, oxygen, thermal buffering, magnetic shielding, and weather systems that can be harsh but are still part of a habitable world. The moon gives none of that. It is not hostile actively. It is hostile passively, by omission. No air, no magnetic field worth relying on globally, no liquid water at the surface, no ecosystems, no automatic forgiveness. Every time Artemis 2 looked closer, the pattern repeated. Beauty first, then the hard truth beneath it. And yet, impacts on the surface were not the only flashes relevant to lunar travel. Apollo astronauts had already reported another kind of flash. A stranger kind, not outside the spacecraft, inside their own eyes. That may be one of the most unsettling details in all of crewed deep space flight, because it means that some of the danger is not waiting for you on the surface. Some of it is already passing through your body while you float in the dark. And to understand that, we need to leave the moon's surface for a moment and enter a much older, harsher environment. The radiation field of deep space. Imagine closing your eyes in a dark spacecraft far from Earth and seeing flashes of light anyway. No alarm panel, no sun through a window. No reflection, just brief streaks or spots appearing inside your vision. That happened during Apollo, and it matters even more now. Astronauts describe different kinds of flashes, some like points, some like stars, some like streaks moving across the visual field. They often happened in darkness, especially during attempts to sleep. The phenomenon was unnerving because it violated a basic assumption. If your eyes are closed, light should not appear. But in deep space, visible sensation does not always require visible light from outside. Cosmic rays are one likely explanation. These are high-energy charged particles traveling through space, accelerated by some of the most violent events in the universe. Supernovae, violent stellar processes. galactic events far beyond any human scale. They cross unimaginable distances, and some of them end their journey by striking matter inside a spacecraft or inside a person. On Earth, we are shielded twice. The magnetosphere deflects many charged particles, and the atmosphere absorbs much of what gets through. The moon sits outside most of that protection, and a spacecraft traveling to lunar distance is leaving behind the layered safety of home. When a high-energy particle passes through the eye, the retina, the optic pathway, or even neural tissue involved in vision, the brain may interpret that interaction as a flash of light. In other words, the astronaut is not necessarily seeing external illumination. They may be experiencing particle physics as perception. That sentence is worth sitting with. The universe can be energetic enough to write itself directly into human sensation, not through metaphor, through tissue. This is why the light flashes matter beyond novelty. They are evidence that deep space is not empty in the way people casually imagine. Empty space is full of energetic events, particles, fields, histories of violence, traveling invisibly. You do not need an atmosphere to know that. You need a nervous system. And that is what makes radiation such a profound challenge for future exploration. A machine can endure certain doses. Components can be shielded, hardened, replaced. A human being is different. Radiation does not simply threaten hardware failure. It threatens DNA, vasculature, neural systems, cancer risk, cognition, long-term health. This is part of why the moon is both a destination and a rehearsal. A few days in deep space is one thing. Years on a Mars mission would be something else entirely. If Artemis is the road back to the moon, it is also the first serious return to a problem Apollo only sampled. What does the deep space radiation environment do to the human body over time? We know some things. We suspect others. And much remains uncertain. That uncertainty is itself unsettling. Human beings prefer dangers with clear boundaries. We are better at fearing a visible cliff than an invisible accumulation. Radiation is accumulation. Particle by particle. Track by track. Exposure by exposure. The astronauts may see a flash and think, for a split second, of wonder. But the deeper truth is less romantic. Something just passed through them. Something ancient. Something energetic. Something they cannot stop with ordinary intuition. That does not mean space is impossible for humans. It means deep space is not a blank stage waiting politely for our expansion. It is an active physical environment that engages our bodies, whether we like it or not. And here the moon plays another curious role. It is not only a place humans travel to, it is also a recorder. Its surface, its minerals, even some of its strange bright swirls, preserve traces of magnetic history and particle interaction in ways scientists are still trying to decode. Which brings us to one of the weirdest and most beautiful lunar mysteries Artemis 2 helped spotlight. Not a crater, not a mountain, not a basin, a swirl, a bright marking on the moon that looks almost painted there. A signature from a magnetic past. A kind of tattoo. There are places on the moon that look as if someone brushed light across the surface. Not smooth lava plains, not impact ejecta, not obvious topography. Swirls. Bright, delicate-looking patterns against darker terrain. For centuries, they baffled observers because they did not behave like ordinary geological features. They seem decorative on a world that has no reason to be decorative. One of the most famous is Reiner Gamma. It is beautiful and deeply strange. The leading explanation for these swirls opens a door into the moon's forgotten magnetic history. Today, the moon has no global magnetic field like Earth's, no broad magnetosphere wrapping around the whole world and shielding it. But parts of the lunar crust carry localized magnetic signatures, remnants, perhaps, of a much older era, when the moon's interior may have generated a stronger magnetic field, or when impact-related and crustal processes locked magnetism into certain regions. These localized magnetic anomalies may act like tiny partial umbrellas against the solar wind. Not enough to create a habitable environment. Not enough to matter like Earth's field does. But enough, possibly, to reduce how much charged particle weathering the surface receives in specific patterns. Over immense spans of time, that difference could preserve brighter material, where the solar wind is deflected more effectively, producing the visible swirls. If that sounds almost impossible, that is because planetary surfaces often hide impossibly slow art. The moon may have painted some of its own bright markings not with water or wind or vegetation, but with magnetism and time. That idea is thrilling because it changes what a lunar landscape feature can mean. A crater tells you about impact. A lava plain tells you about volcanism. A swirl may tell you about invisible field behavior, crustal history, solar wind interaction, and billions of years of differential space weathering. It is like finding calligraphy written not in pigment, but in protection. Artemis 2 could not solve the swirl mystery directly from flyby altitude. But the mission mattered, because it restored human observation to a body whose hidden complexities are still unfolding. It reminded us that the moon is not geologically boring. It is not just gray dust and old footprints. It is a world with unresolved phenomena. And these magnetic ghosts matter for more than curiosity. If localized magnetic anomalies exist on the moon, even in weak and patchy form, they may teach us something about how surfaces respond to charged particles, how space weathering works, and how ancient field histories become frozen into crust. They may also point toward deeper truths about the moon's interior evolution, when it was hotter, when it may have been more dynamically active, and how long those conditions lasted. The moon, in other words, is not just a passive rock. It is a record. And the more closely we read that record, the more it begins to connect the moon to much larger stories. Not just lunar history, but the history of impacts, planetary differentiation, interior cooling, solar wind interactions, and the architecture of the early solar system. This is what planetary science does at its best. It starts with a bright patch on the ground and ends with the formation logic of worlds. Artemis 2 sits right at that threshold. A mission dramatic enough to capture public imagination, but scientifically rich enough to feed questions that reach far beyond the flyby itself. And if swirls are one kind of lunar writing, basins are another. Gigantic ones. Wounds so vast, they redefine the surface around them. The moon is covered in craters, yes, but some impacts were so large, they did not just punch holes. They reorganized entire regions. They produced rings, uplift, fractures, and topographies that still dominate orbital maps billions of years later. Among them is one structure so immense it feels less like a crater and more like an event fossil. A basin at the bottom of the lunar world. And once you see it in context, you realize the moon is not only telling us about itself, It is telling us about the violence that built the solar system we live in. To understand the moon, you have to understand impact at scales. The human mind was not built to visualize comfortably. A small crater is easy enough. A moderate crater can still be imagined. But then you begin to encounter impact basins hundreds of miles across, structures formed by collisions so energetic they behave less like holes and more like planetary trauma. One of the great lessons of lunar geology is that the early solar system was not a serene place where worlds formed gently and settled quietly into orbit. It was violent, repeatedly, catastrophically, structurally violent. The moon preserves that violence because it has never had the weather, oceans, or tectonic recycling needed to erase it. Basins like Orientale are particularly important because they retain concentric ring structures that function almost like impact mechanics frozen in stone. Shock waves moved through crust, material rebounded, rings rose, floors flooded later in some places. The landscape became a geometric memory of collision. When the Artemis 2 crew observed basin structures during the flyby, they were not simply admiring dramatic scenery. They were looking at the aftermath of energy release at scales that help explain not just the moon's shape, but how rocky bodies across the solar system respond to giant impact. This matters on many levels. If you want to understand Mercury, Mars, icy moons, or even the impact history of early Earth, the moon is one of your best preserved textbooks. But the moon's basins do more than teach impact physics. They teach time. On Earth, deep time is often hidden beneath erosion, vegetation, or tectonics. We reconstruct it through layers, isotope systems, and fragmented geological evidence. On the moon, deep time sometimes just lies there in plain sight. A basin can survive as a visible scar for billions of years, which means when astronauts look down and compare an older, degraded basin with a younger, sharper one, they are seeing time not as abstraction, but as texture. Sharper rings, softer rings, brighter ejecta, darkened ejecta, preserved relief, eroded relief, though erosion on the moon usually means impact gardening rather than rain or rivers. In effect, the surface becomes a museum of elapsed violence. And then there is the South Pole, Aitken Basin, one of the largest impact basins in the solar system, so large it reshaped the lunar far side on a continental scale. To call it a crater is almost misleading. It is a domain, a colossal depression, immensely deep, immensely wide, carrying information from one of the most energetic impact events preserved anywhere nearby in planetary terms. Why does it matter so much? Because an impact that large may have excavated material from deep inside the moon, perhaps from lower crust or even upper mantle regions. If so, studying that basin and materials associated with it may help answer profound questions about lunar composition, thermal evolution, and differentiation, how the moon separated internally into layers as it cooled from an earlier molten state. In other words, the biggest wounds may expose the deepest truths. That is another recurring pattern in planetary science. Destruction reveals structure. Violence opens windows. The moon's great basins are not only scars, they are opportunities. And they matter practically too. Future landings near the poles, questions of water ice, cold traps, illumination conditions, and scientifically rich sampling all connect back to the geography shaped by giant impacts. Exploration strategy and ancient catastrophe are not separate things, they are intertwined. Artemis too did not land in those basins, of course, but it renewed human proximity to them, human eyes over terrain that, until relatively recently in history, no one had ever seen directly from that vantage. And there is something poetic about that. The crew was looking at structures made before life on Earth became complex, before animals, before forests, before dinosaurs, before humanity, before language. Structures that have waited through almost incomprehensible spans of time for a conscious creature to look back and understand even part of what they are. The moon specializes in this kind of temporal shock. It makes you feel young, not in a flattering sense, but in the geological sense. Ephemeral. The greatest human empires are almost invisible compared with a basin age. Our entire species is recent dust beside a ring wall, and yet that does not make our looking meaningless. It makes it extraordinary. The fact that a being as brief and fragile as a human can look down on a 4 billion-year-old impact basin and infer the mechanics of ancient catastrophe is one of the miracles hidden inside science. We are temporary, but we are interpreters. And Artemis too carried that interpretive capacity into one of the harshest visual environments humans have ever entered. Still, for all the geology, all the asymmetry, all the scars, the most astonishing image of the mission may not have been a basin at all. It may have been what happened when the sun itself was swallowed, because as if impact flashes, blackout, Earthrise, and the far side were not enough, the crew encountered one more view no human civilization was psychologically prepared for. An eclipse. Not from Earth, not from a mountain, not from a beach or a field under atmosphere, from lunar space, from above the moon. And for nearly an hour, the familiar mechanics of eclipse became something entirely other. An eclipse on Earth is already one of the most emotionally destabilizing events most people will ever see. The light changes wrong. The world feels edited. Shadows sharpen. Animals behave strangely. Temperature falls. Day forgets what day is supposed to be. Now remove the atmosphere. Remove the weather. Remove the birds. Remove the horizon haze and every terrestrial cue that softens cosmic mechanics into something humanly manageable. Now place 4 astronauts in a spacecraft above the moon. That is what makes the Artemis II eclipse so extraordinary. From Orion's perspective, the moon became a black disk against the Sunday, a perfect absence edged by the solar corona. No blue sky around it, no glowing clouds, just blackness upon blackness and a ring of white fire. On Earth, the atmosphere participates in an eclipse. It colors it, diffuses it, transforms the light over landscapes and through air. In lunar space, there is no participating medium, only geometry. The Sunday, the moon, the spacecraft, the eye. That simplicity makes the spectacle feel harsher, cleaner, more unreal. The lunar disk is not dark gray against blue. It is black against void. The corona does not shimmer through atmosphere. It stands out as naked stellar structure, delicate and fierce around a perfect circular absence. No wonder the crew struggled for adjectives. There is something almost offensive to ordinary language about views like this. Our descriptive vocabulary evolved on Earth, under weather and gravity. It is built for storms, fire, oceans, mountains, sunlight through leaves, moonlight over water. It was not built for a black world eating the sun while you float above another black world in vacuum. And yet the eclipse matters for more than visual shock. It compresses the whole mission into one image: light and darkness, beauty and threat, scale and exposure. The moon is obstacle, and the moon is vantage point. The same body that cuts off radio now cuts across the face of the Sunday. The same world that hides Earth now creates one of the most sublime sights a human being can witness. That duality is what makes the moon so rich symbolically. It is never just one thing, never just danger, never just beauty, never just geology, never just myth. It is a boundary object between science and existential feeling, and the eclipse reveals that perfectly. At such moments, the crew is seeing not only lunar scenery, but celestial mechanics made visceral. The clockwork of the Earth-Moon-Sun system, something textbooks flatten into diagrams, becomes immediate and emotionally overwhelming. This is why human spaceflight retains a public power robotic missions rarely match, even when robotic missions produce equally or more valuable scientific data. Human beings experiencing scale in real time transmit something rawer than images alone. They transmit vulnerability. The eclipse is not only beautiful because of what it looks like. It is beautiful because we know 4 people are there, seeing it from inside, a fragile machine. That fragility heightens everything. A human watching an eclipse from a field on Earth is protected by atmosphere, biosphere, civilization, gravity, and centuries of inherited environmental stability. A human watching an eclipse from lunar distance is protected by engineering. Only engineering. A shell, systems, procedure, discipline, and the accumulated work of thousands. The spectacle becomes more intense because the witness is more exposed. That may be a general rule of deep space experience. The less naturally protected the observer is, the more extreme the beauty feels. Because every view comes with the unspoken awareness that the environment on the other side of the window is not scenic. It is lethal. And perhaps that is why the most unforgettable space imagery so often feels edged with unease. We do not merely admire it. We survive near it. The eclipse also closes a kind of arc inside the mission. Earlier, Earth disappeared. Later, Earth rose again. Earlier, flashes appeared on the moon. Now the sun itself is partially consumed. The mission keeps returning to one theme over and over. Occlusion, things vanishing, things reappearing, light blocked by mass, home hidden by distance, meaning emerging through absence. That is not accidental. The moon governs by blocking. It blocks radio, it blocks direct view, it blocks sunlight during eclipse. It blocks our easy assumption that nearby things are known, and in doing so, it reveals. It reveals Earth's fragility by hiding it, then giving it back. It reveals the sun's corona by covering the bright disk. It reveals the roughness of the surface by casting long shadows. It reveals our own emotional architecture by pulling us far enough from home for ordinary perspective to fail. The eclipse was the visual climax of Artemis 2, but not the emotional climax. Because after the view, after the flyby, after the blackout, after the flashes and the swirls and the silence, there remained one more human thread tying this entire mission back to the first age of lunar exploration. A voice from Apollo, a man who had gone there before, almost died returning, and lived long enough to welcome a new crew into what he once called his old neighborhood. Jim Lovell, and the words he left behind. Space history is often told through machines. Saturn V. Command modules, lunar modules, shuttles, stations, rockets with program names that become shorthand for eras. But history is also carried in voices. And one of the most resonant voices near Artemis II came from someone who understood the moon in a way almost no one alive could. Jim Lovell flew there twice, once with Apollo 8, when humanity first broke out of Earth orbit and circled another world. The mission was historic enough to sound fictional even now. Christmas Eve around the moon, Earthrise. Genesis reading, the first human view of the far side. Then again with Apollo 13, the mission that nearly became a coffin in space, a crippled spacecraft, improvised survival. The moon not as destination but as gravitational slingshot back toward Earth. Lovell knew the beauty. He knew the blackout. He knew the terror. He knew what it meant to travel so far that the difference between homecoming and death could depend on equations, improvisation, and luck disciplined by training. So when he recorded a message for the Artemis II crew before his death, the emotional bridge between Apollo and Artemis became tangible. Welcome to my old neighborhood. It is such a simple line, and yet it carries decades inside it. Humility, continuity, experience, blessing. The moon was never owned by Apollo, of course. History does not grant permanent possession of places. But there is something deeply moving about one generation of explorers greeting another, not with possessiveness, but with recognition. I know where you are. I know what this means. Enjoy the view. That last line may be the wisest thing anyone can say about spaceflight. Not because it is casual, because it is hard one. Enjoy. The view is not something a naive person says. It is something someone says after learning that survival and awe can coexist, that procedure does not cancel wonder, that even the most dangerous missions contain moments too singular to let pass unnoticed. Apollo and Artemis are linked by hardware only loosely. They are linked far more deeply by what the moon does to people who see it up close. It rearranges scale. It strips language down. It makes home look different forever. Lovell knew that. Artemis, too, discovered it again. And there is something else profound in the continuity between those programs. Apollo was proof of reach. Artemis is proof of return. Apollo planted a flag in history. Artemis attempts to reopen trajectory. That is why the phrase, "my old neighborhood," lands so well. Neighborhood suggests familiarity, repetition, returnability. Not a one-time stunt, but a place humans can visit again. The moon needs to become that if a deeper human future in space is going to mean anything. Not merely an impossible destination reached once in a glorious burst of political urgency, but a place integrated back into the map of human possibility. Artemis II is one of the first real steps toward that normalization. And normalization, oddly enough, is the highest compliment a frontier can receive. When a place stops being only legendary and begins becoming navigable, studyable, revisitable, then history has moved. Still, the normalization of the moon should not fool us into thinking it is becoming easy. Nothing about Artemis II says easy. Not the blackout, not the radiation, not the bombardment, not the engineering margins, not the emotional toll. What Artemis II says is not that the moon is easy, It says we are willing to engage difficulty again. That willingness may be one of the defining traits of our species. Not intelligence alone, not dexterity, not language by itself. Willingness. Willingness to move toward what is difficult and meaningful at the same time. Lovell's message carried that tradition forward quietly. No grand speech, no bombast. Just the distilled authority of someone who had looked at the same world and understood the strange combination of fear, perspective, and awe waiting there. Enjoy the view. It sounds simple, but it contains an ethic. Do not let engineering make you blind to wonder. Do not let danger erase gratitude. Do not let procedure consume meaning. Do not travel all this way only to forget why seeing matters. That ethic may be more important for the future of spaceflight than any specific mission architecture. Because if human beings go outward and bring back only technical success, the story becomes sterile. If they bring back changed perspective, then exploration reshapes civilization rather than merely extending it. Artemis 2 brought back both. And now, with the flyby completed and the long coast home underway, the final question begins to surface. What was all of this for? Not in the narrow programmatic sense, not just to test systems or prove capability, but in the larger sense. What does the moon actually do to us when we return to it? What did Artemis 2 really discover? The answer is larger than one mission report. And it may have less to do with the moon than with the species that insists on going there. There is a temptation after every major space mission to reduce its meaning to milestones. Farthest distance. Successful flyby. Radiation data. Visual observations. Systems validated. Program advanced. Those things are real. But if that is all Artemis 2 becomes, we will have misunderstood it. Because the moon is not only a destination in missions like this, it is a mirror. What we see there depends partly on what we bring there. Scientists see geological memory. Engineers see constraints. Mission planners see pathways. Historians see continuity. Families see sacrifice. Astronauts see Earth differently than before. The moon does not care what any of us see. And that indifference is precisely what makes the mirror effect so powerful. A world of stone, vacuum, ancient scars, and patient orbit can still reveal us to ourselves because it strips away the environmental noise that usually protects our assumptions. On Earth, life is busy enough to keep most existential truths blurred. We are distracted by immediacy. On the moon, or near it, immediacy changes form. Suddenly, the truths are physical. Home is fragile. Atmosphere is precious. Radiation is real. Distance matters. Silence is not empty. Beauty can coexist with lethal conditions. Human meaning survives even in vacuum. Those are not just facts about space. They are facts about us. Artemis 2 did not land. It did not plant flags or drill for ice or deploy habitats. It did something subtler and, in some ways, more foundational. It restored a human line of sight to the moon. It proved that the route can hold people again, that the spacecraft can carry them, that the blackout can be endured, that the return can be managed, that the old distance is still reachable by living human bodies. And that matters enormously because every future human mission beyond low Earth orbit depends on such restoration. Before you can live somewhere, you have to return to it. Before you can build, you have to circle. Before you can stay, you have to prove you can come back. Artemis 2 is one of those proof points. But there is a danger in discussing the future of lunar exploration only in terms of settlement. Settlement can sound inevitable in rhetoric when it is anything but inevitable in practice. The moon will not be conquered by enthusiasm. It will not be made habitable by slogans. It will remain what it is. Airless, abrasive, bombarded, radiation-soaked, thermally extreme, magnificent. If we go back to stay, we will do so not because the moon becomes easy, but because we become better at living with difficulty. That has implications for Mars and beyond, too. The moon is close enough to test systems, psychology, logistics, habitat strategy, radiation shielding approaches, surface operations, and human endurance in deep space conditions. It is not a perfect analog for Mars, but it is close enough to function as apprenticeship, and apprenticeship is what Artemis 2 begins again. Not the apprenticeship of technology alone, the apprenticeship of presence. How do humans behave when Earth is small? How do crews process beauty under pressure? How do we carry grief into exploration? How do we narrate the unfamiliar? How do we stay disciplined when the environment outside the window is one long reminder of mortality? These are not side questions. They are central. Because the future of deep space civilization, if such a future exists, will depend as much on emotional architecture as on rockets. We will need propulsion and shielding, yes. But we will also need perspective durable enough to survive distance, confinement, risk, and the confrontation with worlds that do not care whether we are there. Artemis 2 offers a first answer. Humans can still do this. And when they do, they still come back transformed. That may be the deepest continuity with Apollo, not the mission profile, not the capsule shape, not the patriotic iconography. Transformation. Apollo crews returned to a world that looked different to them because they had seen it from the outside. Artemis 2 renews that transformation in an era that may need it even more. We are a species overwhelmed by our own noise. The moon offers perspective severe enough to cut through it. That is one reason I think space exploration will never be only about science, resources, or geopolitics, no matter how often institutions must speak in those languages to justify budgets. At its deepest level, human exploration is a philosophical act carried out with engineering. We go because something in us refuses to let the horizon be final. We go because distance exerts pressure on imagination. We go because some truths can only be seen from outside the system that produced them. We go because beauty that terrifies us tends to teach us more than beauty that comforts us. The moon excels at that last lesson. It is beautiful in a way that does not reassure. It is ancient in a way that makes human history feel thin. It is close enough to tempt us and hostile enough to humble us. A perfect teacher. And Artemis, too, listened. The crew saw flashes on a supposedly dead world. They vanished behind the moon and lost the sound of home. They watched Earth disappear and then rise again. They observed a surface more complicated than photographs had prepared them for. They carried memory and grief into lunar orbit. They watched an eclipse in a place no human vocabulary evolved to describe. Then they turned around and came back. That return matters too, perhaps more than all the spectacle, because coming back is what turns revelation into legacy. A vision means one thing in the moment. It means another when it is carried home and translated into culture. Artemis 2 is not just a mission that went outward. It is a mission that brought something back. Not rocks, not samples, not hardware. Perspective. And perspective, once returned to Earth, can spread farther than any spacecraft. The moon is, on average, about a second and a quarter away at the speed of light. That sounds close. It is not. To get there takes days. To survive there takes everything. To understand what it does to a human being may take the rest of a life. When the Artemis 2 crew floated above that world, they saw something older than civilization and harsher than memory. They saw a surface still being hit, a hidden hemisphere shaped by ancient imbalance, a horizon where Earth could disappear, a corona wrapped around a black disk, a landscape that no longer looked like the moon of childhood, but like the fossil of a violent universe. And in seeing all of that, they discovered something simpler and more destabilizing. Not the fragility of the moon, the fragility of us. The moon will outlast us easily. It has outlasted empires that never knew its true face. It will outlast our cities, our languages, our monuments, our arguments, and every generation now alive. The moon is fine. We are the thin thing. We are the brief thing. We are the layer of breath and water and memory on one small, bright world. And maybe that is the hidden gift of returning to the moon. Not conquest, not ownership, not even destiny. Clarity. Clarity about what Earth is. Clarity about what space is. Clarity about what kind of courage it takes to leave one and enter the other. Because behind the moon, where radio dies and home vanishes, one truth becomes impossible to ignore. Space is not built for us. And yet, we keep going. We keep building fragile ships to cross impossible distances. We keep sending human hearts into places that cannot sustain them. We keep reaching outward not because the universe is welcoming, but because the act of reaching changes us. That may be the most human thing of all. To know how small we are and go anyway. To know how dangerous it is and look anyway. To know how brief our lives are and still chase what is vast. So maybe Artemis 2 did not just show us what lies behind the moon. Maybe it showed us what lies behind the impulse to return. Wonder, grief, curiosity, fear, discipline, hope, and the refusal to let the unknown remain only unknown. The moon is not just a destination, it is a mirror. And what we see when we look at it depends on who we are. When we look,